It's our data.
Alright, collisions. What our group did was kind of a little car test to test different types of bumpers. We had wood, rubber, and styrofoam. And so we did a few different tests. So we did wood against wood, rubber, rubber, styrofoam, styrofoam, and then we mixed and matched just so we could see what reactions encountered here. So what you're looking at now are centimeters traveled after the collision. So you see that the styrofoam really bounced back, as did the styrofoam and rubber. Styrofoam and wood, surprisingly, didn't do a whole lot.
That could have been more because it twisted, but...
Right, so we're wondering about a test issue there. Alright, so, yeah, we tested all those materials and collected our data in this manner.
And so...
Go ahead.
So what happened is we think that where'd most of our energy go? It went basically, well, in the case of styrofoam, back into the wheel, basically back into motion. And in some of these, where it basically didn't go anywhere, specifically anything with wood, basically there's a pattern of the rigidity of the substance with basically how rubbery or flexible it was. And so why is this? There's this neat little phenomena when you start dealing with these big organic molecules called bistacking, where the actual rings interact with each other and sort of stabilize each other. Cellulose is very rigid and very structured like this, whereas something like styrofoam has nice long chains, and so these interactions really can't happen as frequently. Most of the other energy went basically into a nice little crack, and a lot of it got sent back into motion because occasionally the cars would twist and spin out.
Noise also. Heat.
Heat. Because if you move these things, you get heat. Yeah. Last thing on this is I sort of liken this to what I call the jelly donut mop, the glazed donut jelly donut sandwich, where that middle ring is a glazed donut, so it's like a ring, and then the pie shell, electron shells, I sort of call the jelly donut that you stack on top of it. It gets all sticky, gooey, and it's a little more squishy and rigid, but it's not so sticky and rigid that you can't unstick it. And plus, it's a jelly donut, glazed donut sandwich. Why would you unstick it? So, what else do we
Next question. Where does the energy go? Did we already hit on this a little bit?
Sort of, yeah. Like
Okay.
noise, we said thermal,
a lot of
mechanical.
transfer just back motion in the opposite direction, especially in the styrofoam cases.
Yeah.
Depends on the case where it went. Like the wood, anything with wood was a really loud crack. The styrofoam just bounced back, and that sort of corresponds to the distance traveled.
So, the next one,
What content matter would you place after this investigation?
I think we would actually go to, like, we were thinking materials,
yeah.
engineering applications.
Yes.
The big one, especially if you go back to our data, is why did the bumpers in cars go from chrome and steel to styrofoam and plastic? Quite honestly, because the energy was not kept back in the system. It's not lost to the sound and everything else, so you survive the crash. You keep going.
I think there are a lot of real-world lessons that you could plug in with this. Once you start getting into engineering, I don't know, like car bumpers, of course, is very much real-world. Just safety materials in general, bike helmets. I mean, that's something kids can relate to. They're filled with styrofoam. And an experiment like this could definitely answer some questions and get kids thinking about those things.
Yeah. And we have the extreme example. Planets colliding bad. Not going to be too well. Final thing, just sort of on types of collisions. We were specifically looking at the energy and the conservation of the energy. So our sort of good collision was our styrofoam on styrofoam where it was elastic. And our bad collisions were sort of like anything with wood. No energy was lost to sound and everything else. Anything else? All right, and we will. I already believe I don't know how to say, the slow motion video captures of the various trials, so you can actually see some of the twisting and turning and bumping, grinding of these cars are online already, and we'll send you out this video. Bye, Matt.
Happy summer.